Let's take a look at the cluster output table and the documents that are produced by the stream that we created. So on the left we have the table output, which includes the document ID, the near duplicate cluster identification, loose cluster identification and similarity, and these have been sorted so that the near duplicates are grouped together and within the loose cluster, and you can see the similarity factor. On the right hand side is a HTML rendering of the documents, as we'll see in a second, that's provided through the file viewer within the modeler application. So we can see that the document identification numbers line up with the actual text files corresponding to them. So let's take a look at the first one. And again, this is a near duplicate clustering. It does not attempt to gauge meaning or relevance. It's simply clustering the documents together so they can be organized into a near duplicate cluster arrangement. So here we have an email concerning presentations, and if we go down to the next one, document 1201, we see it's the same one, and we can follow that down all the way to the last one, which is document 14, and we can see that these are all separate emails. They've been processed, but they're all essentially the same email. And we can see that at the next juncture at 15 that changes, and that set of near duplicate emails continues down there. Now if we take this down a bit, we take it down to somewhere around the breakpoint of 1,000 just to look, and we can see that there is a near duplicate cluster that begins at 985 and continues down, and we can take a look at that. And here's we have a break. We can show where the loose cluster identification number stays the same, but the near duplicate changes with a very low similarity function, but it meets the threshold of 33%. That's all adjustable according to what algorithm you use. So let's take a look. Let's go down to that document location at 985. And as soon as I get there, we can take a look at it. And we can see that that's, again, matching document ID. And this is an email from Ken Lay. It looks like an outline of the summary of the conference call that was held concerning Enron. And if we look at the next document, it's the same one. And if we work our way down, we can see that it's the same email that's located in various and sundry custodians' email boxes. And this, whether relevant or not relevant, is easily grouped together. Now if we take a look specifically now at 1003, we can see that there's an email that came under the loose cluster identification, but they're not the near duplicate. And this looks like generally an email blast that contains obviously some mention of Enron, and it concerns Ken Lay's conference call and assessment of the company. So it is related, but obviously it's not a near duplicate. And so you can see that as you go down, these near duplicate numbers provide a good way of gathering up the documents together so that investigators, reviewers are not looking at the same document over and over necessarily, or worse yet, simply hunting after documents and finding various near duplicate analogs to the original document that they found. And on the review side, documents can be grouped in this fashion so that one reviewer can look at these documents one after another. When it's grouped together for that purpose, the grouping is a bit more sophisticated than shown here, but the principle holds, and that is that you're organizing the documents so that they can be looked at consistently and quickly. So this has a great usefulness, both from an investigative standpoint and an e-discovery standpoint, as well as from a compliance standpoint.